All right, so continuing on with problem number 4, we're on letter C. It says use your answer to part A and the value of k to find the x-coordinates of the stationary points of the graph of y equals g of x. Now, our answer to part A was the derivative. Okay, so what they're hinting at is, remember, to find the x-coordinates of stationary points of a regular graph, that means that they are local maximums or local minimums. And if you were to do the slope of the tangent line at local max or mins, the tangent line would have a slope of 0. It would be a horizontal line. So what they're telling us to do is to set the derivative equal to 0. All right, so what we would do is we would write 0 equals 3x squared plus 12x. We now know that k is 6. All right, so that makes that term 12x, and then minus 15. So what you could do is you could plug that into your calculators, and again, mine is broke, so you're not going to be able to see it, but if you were to type that into your calculators, you could either use the graph or use the table of values, and what you would find is that there are two x values to make this equation 0. It would be x equals -5 and x equals 1. So those would be your two answers for letter C. In letter D, part 1, they're just asking you to find g prime of -1, meaning plug -1 into the derivative. So we would do 3 times -1 squared plus 12 times -1 minus 15. Pretty easy. You just type that in, and you would get an answer of -24. Be careful with that -1. Make sure you put it in parentheses before you square it. Otherwise, your calculator is going to give you the wrong answer. Part 2 of letter D says, hence justify that g is decreasing at x equals -1. All right, thinking back to Unit 6, okay, we talked about graphs, and if the derivative is a negative value at a particular point, that means that on the regular graph, the graph is decreasing. All right, so to justify that g is decreasing at x equals -1, we simply need to just look at our derivative value at that point. And since it is a negative slope, that means it is decreasing. Oops. All right, and then part E, find the y-coordinate of the local minimum. Now, we have two possible x values of the local minimum. If we look at part C, it's either x equals -5 or x equals 1. So if you were to go back and plug the original equation g of x into your calculators, okay, and remember g of x is x to the third plus 6x squared minus 15x plus 5. If you were to plug that into your calculators and look at the graph, you would find that when x equals 1, it is a local minimum. When x equals -5, it's actually a local maximum. So we want to plug 1 in for x. So g of 1 is going to be 1 to the third plus 6 times 1 squared minus 15 times 1 plus 5. And if you type that in correctly and solve, you're going to get a value of -3.